we have to incorporate a lot of devices on each floor, and all these devices, these are all logical links. What I've done so far are wireless, so all these are basically wireless communications until all this data will be sent back to the backend server of the utility, and we have to provide end-to-end security all the way through. And next, please. In one of the, for example, this is one of the analysis that we've done for a floor of 30, for a building of 30 floor, 8 apartments per floor, and smart meter 10, and there are 10 smart meters on the floor, and so on and so forth. And next, please. Next. And it shows, you know, normally if you don't have sufficient channel to increase, because if one channel is not sufficient for data transmission, you may hire another channel. This analysis shows that if you got more than one channel, when you just keep on increasing the power, doesn't mean that the throughput will be increased to 100% like this, but rather it might increase to up only to 60% only because of likely the potential interference from the adjacent channel, okay, or co-channel, okay. So you just keep on increasing the power, may not be necessarily get to a doubling of the data rate. Okay, next. But increasing the power surely will give you an improvement on the delay by what is shown here is 20%. Next, please. Let's take a look at a pilot study in Hong Kong. This is a pilot study done for the biggest utility in Hong Kong in last September for 5 buildings. Each building have 60 floors. So I have to put on each floor a what I call MIU, meter interfacing unit. And this meter interfacing unit is wireless, ZigBee, and horizontally there are 8 apartments. So this MIU can be connected wirelessly to any one of those apartments in which there is an in-home display in the department. So the users within the premises can just press a button, and instantly the users can see the energy consumption from his own meter, so that he knows that how much consumption has been spent. For example, if you just switch on the air conditioner, he might know that how much consumption has been spent on that particular conditioner for that particular hour. And each floor, there's an MIU that so that the wireless signal can jump from floor to floor until it reach either bottom layer or bottom floor or the upper floor, depending what kind of transmission is used. In here, we use the bottom layer, bottom floor, and at the bottom floor, I just devise a data concentrator unit, in short DCU, which convert the signal from ZigBee to either GPRS or PSTN. So I got both here, back to the backend server, okay? And I have to provide all those data, IT end-to-end security here, including data security, authentication, or whatever. Okay, next please. This slide shows the configuration of my system. Now this is the meter room in which the MIU is installed. And this MIU will be connected to all the meters. Normally in Hong Kong, all the meters will be placed in a single meter room on each floor. And on each floor, there will be one MIU on each floor. So 60 levels that you have 60 MIU. But in Hong Kong, there's no, they don't like a number 4. So practically you have about 50 floors. And so in each home, you will have an energy management unit in green color. And then the pink color is the in-home display that the users can carry around. Don't think this is easy. This is really very difficult. The horizontal propagation is very difficult, much more difficult than the vertical transmissions. Okay, next please. And this slide shows the connection, real connection, 8 meters connected to the MIU. And you see 2 antennas because they are horizontal and vertical transmission. Next please. And this is this DCU, which carry data back to the backend server. Next please. And in the home, this is the in-home display that they are using. Users can further add dimmers, and because this utility doesn't want to buy a lot of stuff from us, so the users can at home they just buy more dimmers and more outlets. Then they can use it. They can break down into every corner. Then next please. I've demonstrated a CP MI system which was successfully done in Hong Kong, and very soon I will move to State Grid, and because I was invited to demonstrate similar things at the State Grid to draft so that they can draft the policy as well as the acceptance standard. So hopefully this will be done in Peking. Thank you.
Any question you have?
Yeah. ZigBee also the standard for Japanese smart grid technology?
It's global. It's global.
It's global, okay, good.
Yeah. Are the utilities going to be subsidizing any of these ZigBee units for retrofitting purposes? Because otherwise it's going to be 10, 20 years before you get
Right.
The question, sorry, I repeat the question. Will there be some subsidies from Hong Kong government for these ZigBee energy efficient devices?
Normally, governments in most parts of the world will subsidize. That includes US and Hong Kong. And in my project, it's subsidized. Yes.
You said the pilot study was successful, but what was the goal of the pilot study? What was the objective?
I know the objective, but I need to manipulate a bit to tell you. Well, to my understanding, the utilities in Hong Kong, this concerns the pilot testing in Hong Kong. The utility need to draft a report to the government very soon to see whether smart metering should be done or not. If it is going to be done, to what scale should it be done? Small scale, medium scale, large scale. But it's not easy. You see, at the time I was doing, there were two companies working on it. One was mine, and the other one was the other. And up till now, 6 months later, they still could not deliver. And this company was originally working project for State Grid as well as the utility on wireless, AMR. This is not AMI. AMI, because the data transfer is very frequent in that it's not a simple task, particularly in Hong Kong. Okay, I know that there's a big company in the US who wasn't doing very well in California. So this is not an easy project. So up till now, the other counterparts still cannot deliver after 6 months. So the intention is to see whether they should deploy a larger scale or smaller scale, or even they won't do it at all. So
basically, was it testing sort of the technical capability on the reliability, speed, and the scalability?
Everything.
At the commercial level.
Yeah, including the political, whether there's any political issue or
But
not.
right now, it's all one way. It's not any
Two-way. This is two-way. Mine is two-way.
It's not like there's a variable pricing and you can actually actuate your, washer to do something else just because your power plant tells you to, right? It's still just reporting one way. This is a consumption, this is the data.
Yes, technically it's two-way, but what you mentioned is correct. They use the consumption of a certain month as a reference, and then the other months they will measure whether the user can save up energy or not, and then they will get rebate. For that reason, they will get rebate. But this is a simple test because they don't want to enforce at this point, because they might they are very much afraid that that may stir up a political issue. So they just give it a test to see whether this is good or not.
Can you talk a little bit about the data integrity and reliability, or
So
is
far,
that secret?
no, this is not secret. We were ranked number 1 in that company, and our service level is over 99%. We can't get 100%. There must be missing data, but we still can achieve 99%. Whereas in California, I was told that those big companies could not achieve this figure.
But what was the transmission rate? Like, were you sending data every minute, or
Less than 256 kilobits per second.
How's the system going to work if only a few flats sign up? I mean, a similar case is that if I buy an EV and I want to charge in my private car space, I have to get 80% of the car park owners to upgrade the system to allow me to pay for installing a meter. So, for example, you had 60 floors with a simple meter, but if you go to retrofit, even if there's subsidies, nobody takes it up. Only maybe one flat per floor. How's
the question is, correct me if I'm wrong, how are people going to add in their smart meters or replacing the devices by other smart items?
No, it's how is the system going to work if only a few people go into it, and generally you need at least 80% of the people to.
You need the infrastructure to be there first, like the vertical part, the vertical portions, that will cover all the wireless coverage. So that's not an easy part. So individual users can buy display, EMU, dimmers, power outlet, etc., or interact converter. They can buy it afterward. But initially, there must be an infrastructure like the MIU and DCU. Otherwise, they can't do it. So there must be subsidy. But this is beyond technical level that I cannot answer for it. Yes.
Last question.
Just a question about these millions and millions of sensors. Even if the power consumption is 1 watt, and in your HAN, this is going to increase the power consumption in the first place.
Yes.
If you were in Hong Kong, we must be, I don't know, counting, maybe 1 trillion sensors will be needed. Even if it's only 1 watt, or even half of a watt, that's going to increase the power consumption, and CLP, Shortcom Electric, are going to need to build a new power station to power it all.
Very, very smart questions. The question was, the device itself burns energy. So the gentleman was talking about 1 watt, but in fact 1 was very large. So even if you're talking about a few tens of microampere, understand by mole, if you multiply all the sensors together, that will give you quite a big figure already. Is that the question? Yeah, this is very smart questions. Yes, it's true. But with all these devices in place and all those intelligence at the back end or at a certain server within the premises, we can, according to the behavior, save up energy by 10 to 20% versus the energy burned by the devices itself. This is the saving is still there. You have to look at it at a macroscopic scale, but not an individual scale. If you just say one device, then it burns energy. You don't use it. But you're talking about, for example, if I am here because I'm using my Zigbee system, if I go away and automatically all this lighting will be shut down and all the air conditioner will be shut down altogether without taking care of it, then you will make sure that there will be no waste because of the wireless networking. So on a macroscopic scale, you will have saving, and also we can manage because you have wireless them all together. So you are right in some sense, but.
Do you have an idea of the saving? Sorry, the saving as opposed to the extra utilization?
Yes, as I mentioned in one of the slides there, in research at Japan and Sweden, it shows from 10 to 20%, just because of the human behavior. Because you may forget about to turn down, to shut down this lighting, this AV equipment, even understand by mode, it kills 2% of electricity. So you may have, in fact, there can be more saving, but I don't have sufficient time to tell you about this tonight.